So here's another example of the two-sample mean comparison test. It says test the claim that two samples described below, so this one's called sample A and sample B, instead of 1 and 2 it's A and B, come from populations with the same mean. That's the null hypothesis. Assume that the samples are independent, simple random samples. Test the alternative hypothesis that the two populations have different means. So this isn't saying larger than or smaller than, it's just saying different means. That means it's a not equal to, it's a two-tailed test, okay? At the alpha equals 0.02 level of significance, and then confirm with a confidence interval, okay? All right, so step one, we're going to state the null and alternative hypotheses. All right, so our alternative hypothesis is that the mean of A is not equal to the mean of B, because it says have the alternative that they have different means, okay? All right, step two, well, all of our important statistics have already been identified and summarized right here, so we'll refer to them, but we do need to point out that the alpha is 0.02, and we need to identify the degrees of freedom. So remember, to get the degrees of freedom, we need to look at the n's. Here we have n is 8. Here we have n is 5. 5 is smaller than 8, and 5 minus 1 is 4. And therefore, our degrees of freedom is going to be 4. And then we're going to say that we're going to reject H sub O if our p-value is less than our alpha, which is 0.02. Okay? All right, step three, we're going to identify our critical t-value, our t star, right? And we're going to go get that in the NumWorks calculator. Now let me remind you that because it's a two-tailed test, we're going to have to cut the alpha in half, okay? So when we plug the alpha in to get the critical t-value, we're actually going to put in alpha divided by 2, which is 0.02 divided by 2, which is 0.01. So here we are. We're going to go down to distributions, okay. Going to go down to students t, okay. We're going to put in degrees of freedom 4, okay. Next, we got to switch over to a right tail test because we're a right tail feature, or option, I guess I should say, because that's how we do the two-tail test. And we hit OK. And we're going to come over here to the p-value. And instead of putting in 0.02, we're going to put in 0.01 because we had to cut the alpha in half. And that's going to give us 3.746947. And so technically, it's actually going to be plus or minus 3.746947. But just so you remember, we're actually only going to use the positive version of this when we do the rejection rule, because we're going to say reject H sub O if, okay, if what? Well, if the absolute value of our t statistic, because it could come back as negative, if that is greater than 3.746947. Okay, that's our rejection rule. And we've got our critical t statistic, which we will also need for the confidence interval. And then for step 4, we're going to identify the standard error, and we're going to identify the t statistic, but we're going to identify them in NumWorks. So we're going to go over to inference here. We're going to hit OK. And for the standard error, we're going to go into intervals, hit OK. We're going to go down to two means, OK. T interval, input statistics, and here's where we're going to put all our numbers in. So now we're going to call 1A. So this is going to be X bar sub A. All right, X bar sub A is 113.5. 113.5, enter. S sub A, the standard deviation from A is 9.77. 9.77. Execute. And then N sub 1 is going to be N sub A, which is 8. So 8, enter. x bar sub 2 is going to be x bar sub b. That's over here. That's going to be 101.8, 101.8. And then the standard deviation from over there is going to be 7.71, 7.71. And the sample size from over here is 5. We'll put 5. And then the confidence level. Now this is a two-tailed test, so we can actually just do 1 minus alpha for the confidence level. So 1 minus 0.02 is 0.98. So we're going to do 0.98. But I told you before, we don't really need the confidence level just for the standard error, because the standard error really only needs just the S's and the N's. So here we are, standard error 4.880618. So our standard error is 4.880618. Now, if you want to confirm that by using the formula, pause the video right now and go ahead and use the formula and confirm the standard error. But now I'm going to go on, I'm going to go back to inference, and okay, and I'm going to select tests this time so I can get the test statistic, and I'm going to go down to two means, a t-test, and this time my null hypothesis is actually not equal to, so I want to select this one, not equal to. Then I'm going to go down to next, input statistics, x1 is XA, which is going to be 113.5, 113.5, and then standard deviation over here is going to be 9.77, 9.77. The sample size over here is 8. The sample mean from the second one, which is B, is 101.8, 101.8. There we go. And our standard deviation is going to be 7.71, 7.71. Okay. And then our sample size is 5. So put 5, enter. And then our significance level is 0.0, whoops, hang on a second here, 0.02. Our alpha is 0.02. Then we'll hit next, and here's our test statistic. Remember, we ignore these other things. We just need our test statistic. 2.397. So 397. Let me go back here. 2.397, 397, 237, 237. Okay. And now, based on this t statistic, we're now going to go identify our p-value. So our p-value, we're going to go to distributions. Oops, here we are, distributions. And let's make sure we got the degrees of freedom correct. We do. 4, next. And we have the right tail test. Now, right in here, we're going to key in our t statistic, which is 2.397, 2.397, and then 237, 237. Execute, and our p-value is 0.03. Now, this is a two-tail test, so we actually have to double this. We have to multiply this times 2. So I'm going to grab another calculator right here that I have, and I'm going to key in this number, 0.03728977. I'm going to multiply it by 2, and it gives me 0.07457954. Okay, and so remember, the reason we're doing this is because it's a two-tail test. With a two-tail test, we have to double the p-value. So we have 0.0745 8 is the 80. So let's just put an 8. And so now look, this p-value is not less than 0.02. This is larger. 0.07 is larger than 0.02. So we're going to say do not reject H sub O. Why? Well, because P is greater than 0.02. It gets better. Look, is our T statistic greater than 3.747? No, it's smaller, 2.397. That's smaller than 3.747. 0.747. And so the other reason is because t is actually less than the critical value or well, let's say the absolute value of t is less than the critical value of 3.746947. Okay, so that's two good reasons to do not reject H sub O. So, so we're testing the alternative hypothesis that they have different means. Well, they don't. They don't have different means. The mean, we're gonna stick with the null hypothesis that the mean of A is equal to the mean of B. Now we can confirm this with a confidence interval. So when we do our confidence interval, we're looking to see if 0 is going to be on the confidence interval. And so what we're going to do is we're going to take our XA and subtract our XB, which is 101.8. So we're going to do 113.5 minus 101.8 plus or minus our t times our standard error. We're going to multiply these two numbers by each other. 4.88618. So let's go to the calculator. Let's do the t for, oh, no, not these two, sorry. We need the t star, we need the critical t. So 3.746, 947 is what I get for not writing it down. I mixed them up. Okay, so there's my t star times my standard error, 4.880618, and I get 18.287, so 18.287,417. And this 113 minus 101.8, let's see what that is. 113.5 minus 101.8, and that gives me 11.7. So what we have here is 11.7 plus or minus 18.287,417. So we're going to do 11.7 minus first, okay? So 11.7 minus 18.287,417, and that gives us negative 6.587. So negative 6.587. And that's going to be less than or equal to, and then look at your notes if you're not sure, it's going to be mu sub A minus mu sub B. Now in your notes it says mu sub 1 and mu sub 2, but over here in our null hypothesis it's mu sub A and mu sub B. And then that's going to be less than or equal to, now we're going to take these same two numbers and add them together. So 11.7 plus 18. So we're going to move over this way, we're going to take away the minus, make a plus, and we get 29.987. 29.987. And look, we have a negative number here, we have a positive number here. That means 0 is, that's sort of ugly, is on the interval. And since 0 is on the interval, we do not reject H sub O, okay? And we have confirmed our decision, do not reject H sub O, using a confidence interval. So there's a second example. Both of these examples were right off of your worksheet for, I think, lesson 19. And so hopefully you got a head start. There's 3 more problems that you can do, and you can check your answers to the key. Hopefully this helped you a good bit.